Now it turns out that the best way to measure paleoclimates, climates of the distant past, is using ice cores from Greenland and Antarctica. We've already seen some methods like tree rings and ocean floor sediments and forams, and we've learnt about the remarkable use of oxygen and hydrogen isotopes, and that also applies here. So people measure cores, they drill down. It's a difficult and painful scientific process, being in the Arctic or the Greenland or Antarctica. The idea is that in these cases you've got ice sheets that are in some cases 4 kilometers thick or more, a huge layer of ice that's been laid down by snow falling year after year. Now once again, just like for ocean cores, there are some places where this ice is flowing sideways and it's all muddled up, but there are some places, it takes a bit of finding, but you can find some places where the snow is just piled up in the same place for hundreds of thousands of years and not moved sideways, and so you can actually get samples of ice from the distant past. Here's what an ice core looks like. What you can see here is just one slice. They will take a whole bunch of things, then go down and drill a bit further, and some of these things go all the way down through many kilometers of ice. You can actually see a black layer here. This indicates there was a volcanic eruption in that particular year and laid a cloud of dust upon it. Here you can see a refrigerated storeroom where some of these ice cores from one of these things are stored. They have to keep it cold all the time, and there are many kilometers of these ice cylinders, and there have been many of these places who've done the measurement. Now you can date things quite well usually, because there's often an annual cycle, annual stripes each year. You tend to get the lighter coloured during the summer and the dark coloured ice during the winter. So you can teach a year. You can see how much snow fell that year. You also can find the oxygen isotope ratios vary between the summer and the winter, as the temperature is different, as we've already talked about. So each core you can try and count all the years backwards. You can also cross-check. If there was a big volcano, it might put ash across all the ice cores drilled anywhere in at least Greenland, and so you can cross-check and work out which year for one ice core matches the one from another year, because they've got the volcanic ash that matches between the two. So you can date these things very precisely to the year or even to the month sometimes, and you can go a long way back. And also, and this is crucial, very often there are bubbles of air trapped inside the ice. Here's a sliver of ice, and you can see the little bubbles in. And what you can do with modern analytic techniques is open up these bubbles and measure the composition of the air. So you can actually measure how much CO2 was in there. What was in the atmosphere at the time that this ice was laid down? So you can look at the oxygen ratios to measure what the temperature was, and you can measure the CO2 from the bubbles.